Okay, this is an investigative task. This is the first one I've given you of these this year, I think at all. It's kind of a fun one. It's an interesting brain twister, and that's sort of what they intend to be. They are intended to take a little bit more time. Some of them do, some of them don't. Um, this one can be pretty simple. So they have these arrangements, and we're going to be looking at two different ways that we can assign people into these arrangements. The first way is going to be using a coin flip method, and the second way is going to be using a chip method. I'll do the chip method on a different video just so that it's not super long, nothing super long. So if I'm flipping a coin, we're going to go in the same order here, man 1, man 2, woman 1, woman 2, and sort of woman 2 just sort of ends up getting stuck in whatever group's left is what ends up happening here. But man 1 flips a coin, and he has a 1 in 2 probability of getting put into the treatment group. So he flips, he gets his head or tail or whatever it is that gets him into the treatment group, and he's in. Man 2 steps up and he flips his coin. He's got a 1 in 2 probability of getting into the treatment group. So now the treatment group is filled. Woman 1 and woman 2 don't need to flip, they just go directly into the control group. So this is going to be 1/2 times 1/2, which is 1/4 or 0.25. Okay. Now, arrangement B, man 1 flips. He's got a 1 in 2 probability of getting put into the treatment group, which he is. He's put in there, he's won the ticket or whatever. Man 2 flips, and he's got a 1 in 2 probability of going into the treatment or the control group. The probability is the same for either of these groups. The fact that he flipped the coin gives us that probability. But the treatment group isn't filled yet. So now it goes to woman 1. She flips the coin. She's either going to get into the treatment or the control. And then woman 2 is left with whatever's left, which is the control. So I've got 1/2 times 1/2 times 1/2, which is 2 times 2 times 2 is 1 in 8. So there's a 1 in 8 probability that arrangement B will happen. C. Man 1 flips, he gets into the treatment. Man 2 flips, he's into the control. Treatment group is not filled, so woman 1 flips, and she also gets into the control. The last flip is unnecessary because woman 2 is going to fit right into there anyway. They're going to push her in. So same calculation as arrangement B, 1/2 to the 3rd power is 1/8. Okay. All right, arrangement D. Man 1 flips. He's in control. Man 2 flips. He's also in control. The control group is now filled. We don't need to do any more flips. Woman 1 and woman 2 get pushed in automatically, so that's going to be the same probability as treatment A, so that's going to be 1 in 4. There's only 2 flips needed. Sorry, I've been writing down there and you guys couldn't see that. So arrangement A 1/4, B 1/8, C 1/8, D is 1/4. And okay, man 1 flips. So 1 and 2. Man 2 flips, 1 and 2. The treatment group isn't filled, so woman 1 flips, and we have our control in our treatment group, or one of the groups is filled. So filled, filled. Once one of the groups is filled, we're done. So this is 1/2 to the 3rd power again, or 1/8. And last one, which is going to have to be 1/8. Man 1 flips. He's in control. Man 2 flips. He's in the treatment. Neither group is filled. Woman 1 flips. That fills the treatment group, and we have 1 and 8. So now we've completed our table. It says for the sequential coin flip method, sequential, by the way, is in order, what is the probability that man 1 and man 2 are assigned to the same group? Well, they're in the same group here and here. So those are dependent events. So this is going to be 1/4 plus 1/4, which is a 1 and 2 probability that they're in the same group. So, okay? And you'll see the other on a different file.